Now welcome to Edu-aider, Mathematics with Edu-aider. Please do subscribe. Please do subscribe. Subscription is free. If you want to reach me on my contact, you have 234-8164-869470. You can reach me on the contact, and please do make your comments, likes, and share. Thank you. Today we'll be talking about differentiation, that is differential calculus. So under this, I'm going to be talking about the first principle. The first principle, how does it go? Let's illustrate with this. Here we have a function. Let's say we have a function f of x, which means y depends on f of x. Anything y gets is as a result of the function of x. So here now, we have 2 points on this curve. Look at this curve. Point P, that is P of xy, and we have Q of x plus change in x and y plus change in y. Something happens. There is a little increase in y as a result of an increase in change in x, that is in x. So, if we are to look at this, observe this, you have QL to be equal to change in y. From here to here is change in y, that little increase. Then, from this PL, it is change in what? PL is change in x. Are you following me? Good. So here, if we have to calculate, because this is a what? A curve. If you are not to calculate the slope of this, the slope is known also as dy dx. That's what we are going to be dealing with in calculus. The y dx most especially of functions. But here, because we are dealing with a curve, it has a slope, and that slope is known as dy dx, and that dy dx is also known as this change in y upon change in x, that is QL over PL in this case. Do you get? Good. So here that becomes change in y, change in x, and also we should know that our dy dx can be equal to the limits of this, the limits of change in y, change in x, as change in x tends to 0. So once you get the limit, you have that is equal to the y dx. So here, this is what we're going to be doing. We are going to be solving 2 examples in this video. Please pay attention and do watch carefully with much attention. So here, let's have our first example. Example 1. Now we are solving this by first principle. We have to differentiate this function by first principle. So what will we do is a simple one. So you have your y equals to 3x squared. And whenever we are saying this, there is an increase in y as a result of what? Increase in x. So this is a function of 3x. So y is a function of this. Which means whatever this becomes will determine what y will become. Do you get? So here we move. So we say y plus change in y, increase in y, that can be equal to 3. We are dealing with x. Don't forget, so we have x. There will be an increase in x. And x was a degree 2, so everything becomes degree 2. Simple. So we move. So we have y plus change in y can be equal to this. You can expand this, change in x. They have what? X plus change in x. And that becomes what? 3 open bracket what? X squared. This time this you have plus x change in x. This times this now, we have the same x change in x. Then plus this times this, that becomes change in x. Everything all squared. Then you have this. So y plus change in y, that can be equal to 3x squared plus 3x change in x. Okay, there's already x changing x changing, that is 2x changing x, right, times 3. That will become 6x changing x plus 3 changing x squared. You get that? This will give us 3x squared, 6x changing x, this changing x squared, then 3 times that. So we now have, subtract y. Subtract y from both sides. Please follow this direction. So here we have y minus y plus change in y. Don't forget, recall y is this 3x squared. So we bring it into, instead of writing y the right hand side. So we have 3x squared plus 6x change in x plus 3 change in x all squared, then minus 3x squared. So that means this and this will be gone. So we are having this and this gone. Then change in y can be equal to 6x change in x plus what? 3 change in x squared. Now, what do we do next? We are looking for what? Change in y, change in x, which is dy dx. So what do? Divide through by what? Change in x. Divide through by change in x. Divide through by change in x. Do you get that? So this, we cancel this. This, we cancel this. We have 1 left. So we can say we have our change in y, change in x, which will be equals to 6x change, nothing here again. Then we have plus 3 change in x. We said dy dx is equals to what? Recall. Dy dx is equals to the limit of change in y, change in x, as change in x tends to 0. Do you see that? So that can be equal. So what does that mean? That means our dy dx, as this guy tends to 0, this becomes 0. So that becomes 6x. So the differential of this is 6x. Dy dx of y equals to 3x squared is 3x. Using our first principle, any method you use to get the same answer. Example 2. So example 2, we have y to be equal to the square root of z minus 1. Now we are solving this also by first principle. So how do we go? Follow the same approach. Y plus change in y can be equal to what? We have y plus change in y equals to the square root of z plus change in z, put in brackets, minus 1. It is, this one now, y is now a function of what? Z or z. So here now we have this. So what do we have? We have y plus change in y minus y. That can be equals to what? Z plus change in z minus 1. Then minus, instead of minus, we are subtracting y from both sides now. But y is this. So you have this z minus 1. Do you see that? So this and this, let me use my red. So I have this and this gone. So I can equally say my change in y can be equal to this z plus change in z minus 1 minus z minus 1. Do you get that? So I can equally write this. I can say over this. I can write this z plus change in z minus 1 plus, you have this change in z minus 1. This plus, I want to bring the same thing that is here, I'm bringing it here, such that we have them as conjugates. So we have z plus change in z minus 1 plus you have z minus 1. I don't know, check that if you understand that. I expect you get that. So what have we done? All I've done is just to this will cross out this. This and this are the same thing. I mean this and this. They are the same thing. So this is like it's just like multiplying changing y with 1 over 1. This is this in this 1. You get? So we are good to go. I have reason for doing this. This is just manipulation. And that's what we do in mathematics. If you don't manipulate, you get results. So here what do we do now? So if this should multiply this, what are we going to have? Let me put this in brackets. Is the square root of this times the square root of this. You have the same thing in the square root. What does that become? If you have root 2 times root 2, what do you have? You are going to be having what? 2. So eventually, so we have this change in y can be equal to z plus change in z minus 1. Yes, they are all in the root. This times that, there is a minus here, there is a plus here. So they eventually cross out. I can show you anyway. So I can have this times this has given us this. This times this we have root of plus root of z minus 1 times root of z plus change in z, then minus 1. This times this, then this times this, you have minus the same thing that you have here. You have z minus 1, open bracket, we have what? Z plus what? Change in z minus 1. This and this. Then we have this times this. That will give you minus z minus 1. Then everything over what? We have z plus change in z minus 1, then plus z minus 1. Don't forget, this and this will cancel out. They are the same thing. Positive, negative, and they are the same thing. So gone. So here, we are going to be having z plus change in z minus 1. Then here, you have minus, put this in bracket please, this times this, so minus this. So that becomes change in y will become z plus change in z minus 1 minus z plus 1. Everything upon, you have z plus change in z minus 1, then plus what? Z minus 1. So what happens? This and this gone, this and this gone. So you have this to be equal to change in z divided by the square root of z plus change in z minus 1. Then you have plus z minus 1. Do you get that? So here now, this is what we are left with. Permit me to clear up this place so we can finish our solving there. So we have this. So what? Change in y, change in x. You get that? That's the next step. So we have change in, we are dealing with change in z. So change in z or change in z, we have this. Then we have z plus change in z minus 1 plus z minus 1 divided by, so that will become 1 over change in z. You get that? So we are going to that both sides, so this will cancel out this. So what do we have now? We now say our dy dx, which is equal to what? Change, or the limit of change in y, change in z, our dy dz, as change in z tends to 0. So what do we have? We have 1 upon, this becomes what? Z plus 0 minus 1, then plus square root of 0 minus 1. Oh, sorry, it's z minus 1. So that becomes what? 1 over the square root of z minus 1 plus the square root of z minus 1. What does that become? That becomes 1 over 2 square root of z minus 1. This is our dy dz. We are good to go. Please like, comment, and share. Thank you very much. We'll see you in the next video.